look at our syllabus, okay, we've kind of changed a little bit, but this is the October the 17th, and we're going to finish chapter 6, and then next week you'll be out for the fall break. Is that right?
Why did I think fall break was in November? Are we off for a week for Thanksgiving?
I don't know. We're going to be out 3 weeks.
Oh, yeah, that's right.
Some will be gone, so that may be what it is. Okay, so we got the fall break, and then we'll come back and take a test on everything that we've had up through algebra, and then do a start on chapter 9, and then we'll finish 9, and then I'm going to be out of town these days, and then we have the forum on this day, so it'll actually be 3 in a row that we will miss, and that's going to be kind of hard. And then we'll come back and then finish 12 and 13, maybe. we hope we'll get through with that. But anyway, and then review, and then have a test over everything that we've covered. Okay. And that forum is on Vietnam on the 28th, and of course you'll get extra credit for that if you can come to it part of the time. Okay. Now,
will we have class on 28th November?
No.
No, we don't have class.
No, because
Thank you.
we'll be going to the forum. And we will also won't have it on the 14th or the 21st. Okay. Let's see. We, since Bobby was not here, I wanted to look a little bit at what we did in chapter 6 before we did the review. Okay, we did these problems here, which were just equations, and I'll give this to you in a minute so that you can see if you got these right or not, and you can't even see that because it's so light. But to review what we did, we had problems like this. Okay, we all know what the answer to that is, but to work it in a systematic way, whatever you do to one side of the equation, you do to the other. Or you move it to the other side and it changes the sign. But anyway, then you can put this back in, 3 plus 2, and it does equal 5. So we have that type of equation. We have this type of equation, which has a subtraction sign. So we do the opposite, or we add. We can put it back in. 11 minus 3 does equal 8. We have problems like this, okay, which it is multiplying. So we do the opposite, or we divide. And then we can put that back in here. 3 times negative 6 does give you negative 18. Then we have problems that look like this, or it might look like this. It's the same thing. This is like dividing. This also is dividing, so we do the opposite, or we multiply. And that makes it go away, and then 2 times 12 is 24. So half of 24 is 12. Same thing here, multiply by 2, so x is 24. 24 divided by 2 does give you 12. So you have these 4 basic types of equations. Then you combine different types. You might combine this one with the top one, something like that. And so this is called an AX plus B equals C type of equation. It can be switched all the way around. It can have something like this, 1/3 x minus 5 equals a negative 12, or something like that. Okay, it's combining one of these with one of those. And so since these are connected, we don't do anything with it, but we have to move this one, so we subtract 2 from both sides, so 3x is equal to a 3. Then it turns into this type. So we do the opposite. Instead of 3 times x, we do the opposite, or we divide by 3, and so x is a 1. You can always put it back in and see if it works out. Now, also, this shows you why you have to know each little bitty step, because it's hard to figure out what x would be in that by just guessing, you know, and looking at it. So we add a 5. So 1/3 x is equal to, I think that's 7. And that would be a -7. Okay. And then we'd multiply by 3/1. So x is equal to -21. Okay. I probably could have looked at that all day and not been able to figure it out. But just by using the little steps that we did, then we figured them out. Then they got harder and harder. If you look on, let's see, well, some of the ones you had for homework would be something where you would have like 4x plus 2 equals an 8x minus 7, something like that, where you have variables on both sides and numbers on both sides. So you wanted to move your variables to one side, your numbers to the other, because the whole objective in an equation is to get x on the side by itself and figure out what it's equal to. So if I take 4x away from both sides, I have 2 equals 4x minus 7. Then this turns into that type of equation, and I already know how to work that. So I add a 7. So 9 equals 4x. I divide through by 4, so x is 9/4, or 2 1/4. So you can leave it like that, or you can, you know, make it in a simpler form. Then we had problems like this. Okay, something like that. And they get harder and bigger and longer and all that. But if you can figure out each individual little step, then they're not hard. What property do you use to work both sides of that? Distributed. Good. So 3 times x is 3x, plus 3 times -1 is -3. Put down what's left. 4 times x is 4x, plus 4 times -8 is -32. Okay, so we work like that, just do different parts of it. Okay. Alright, then we have to combine these over here, so 3x plus 3 equals 4x plus -32. Okay, we have x's on both sides, numbers on both sides. So I want all my x's on one side, so I'm going to subtract this. So I'll have a 3 equals an x plus a -32. Then here's my x. I want this on the other side, so I add a 32. So that's 35 equals x, if I didn't make any mistakes. Okay. And you can always put that back in and see if it works out. Okay. But anyway, so equations, you just start out with something small, the 4 basic types, and then you go from there. Now, the next thing we had is, why in the world do we need to know how to do equations? And that is problems like this, where we had 9/5 c plus 32. And you wanted to find out, say on number 17, what 20 degrees Celsius is equal to. So all you have to do is write the problem down, and in place of c, put in 20, and then solve the equation. This is an ax plus b equals c type of equation. Okay, so this is multiplying, so I'm going to cancel 5 1 24 times. 4 times 9 is 36 plus 32, so that gives me a 68 if I didn't do anything wrong. Okay, and so most of those were fine. Now, some people had trouble like with 19 or 20. I'm on 20. Okay, and it said to use this one. C equals 5/9 times F minus 32. Okay, so in this one, if we have 32 Oh, wait a minute. No, it's 15. Okay. 15 minus 32. It's going to give us what it is in Celsius. Okay, so first I have to do 15 minus 32. So 32 and 15. Is that 17? Negative. Okay. Then multiply this times this. So 17 times 5. Is that 85? 85 over 9, and that was a negative. And then divide this out, so it comes out to what, 9 and 4/9 or something like that. Real weird number. And so when you're working it, you think, I don't know if I did that right or not. That's crazy, you know. But it's because you ended up with a negative number right here, you know. And so you can work problems and not have any idea what you're talking about, but be able to get the answer if you don't make any mistakes. Now, so you just use whatever formula they give you and then work it out.
So these big, like whenever you see people with those big chalkboards and they're just going on a problem, it's basically they're just doing this over and over in sections and sections and sections.
Basically, yeah, you've got different problems. You can check that in a minute. See how you did.
Another thing,
Uh-huh.
on a calculator,
Uh-huh.
the problems that I've been having, what's a good one to go get that's not like outrageously expensive? Where I can figure out the square root of 2 and not get the square root of 2 when I put that.
Right. A lot of yours is probably okay. You just probably need the booklet that goes with it that tells you, because it's probably in the wrong mode or something. Because it can be in a degree mode, which is what you usually want it in, or it can be in a different mode, and nothing will work out right. But let's see, what kind do you have, David?
Texas Instruments TI-30XA.
Okay, that's probably okay.
I got an XS, the same thing. You got.
Okay. But I'm sure yours is fine. It's just probably in the wrong mode. And without the book, I don't know how to change it either.
It almost ended up in the street the other day.
Yeah, I understand. Okay, now, some of the other ones that you may have trouble with is like number 21, which is find the interest using this formula. I equals PRT, which is the principal times the rate times the time. So it says find the interest if you have $200, which is the principal, times the rate. The rate was 6%. Okay, before we can work a problem, if it's in percent form, we have to change it back to a decimal, so that's 0.06 times the time, and it was 5 years. So all you had to do is multiply those out on your calculator. Anybody remember what the answer was on that one?
200 times point.
Times 5. That's number 21.
60.
Okay, 60. Okay. All right, then on 22, you had the same thing, but it was 3.5% interest. So you drop that off, move it 2 places, so 0.035 times 5. Okay, and multiply that out. And what was the answer on it?
35.
35. Okay. All right, so, just,
This, I'm sorry. These are two I didn't know because how do you
Okay.
rationalize that?
Okay, this one is x is greater than 1. This is a inequality symbol. So any number bigger than 1 will solve that problem. Like if I put a 2, 2 plus 4 is 6, and that is bigger than 5. I could put a 7.
Gotcha.
Anything bigger than 1 will work it out. That's a good question. Okay, now another thing like that, if you have a 2x is greater than 10, and you're trying to find out what x is equal to, this is the same thing as a 2x equals 10 type of problem, right? So what would you do to both sides?
Divide by 2.
Divide by 2, so x is greater than 5. So that means that anything bigger than 5 would solve this equation. If I put in a 6, 2 times 6 is 12, and that is bigger than 10. If I put in a 5.5, that would work. Okay, now the only thing that's different when you have an inequality is if you multiply or divide by a negative. Okay, when you do that, let me show you what happens if we leave it like it is. It says anything bigger than negative 5 would be greater than 10. So if I set a 7, okay, negative 2 times 7 will be negative 14. That's not bigger than 10. So what you have to do, if you multiply or divide by negative, you must turn your inequality sign around to get the right answer. Okay, so that's just a rule you have to remember. If you multiply or divide an equation by a negative, you must turn your sign around. Okay, now, so we had that worksheet, and now then we did these chapter review problems. This was on page 283, and I'm assuming you looked in the back of the book and checked them. Okay, are there any of those that you need to see worked out? Okay, this was talking about prime numbers, evaluating using a number line, finding a fraction, making it a terminating or repeating decimal, write it as an improper fraction. This was like reviewing all sorts of things that we've had. Then we got over to like 5-4, where you had to remember how to rationalize something like square root of 50. Remember how to do that? You break it down into something with a perfect square. So that's like 25 times 2. Square root of 25 is a 5, and then what's left is 2. And so this is considered simplest form, okay? It's not solved, it's not an exact answer, it's just in simplest form. Then you did the properties, like on 81 through 90. This is on page 284. Okay, we had an x plus 2 equals a 2 plus x. Okay, let's just look at some of those just a minute. X plus 2 equals 2 plus x is commutative. What about 5 times m equals m times 5? Commutative. 1 plus 2 plus 3 equals 1 plus 2 plus 3. Associative. 4 times, parentheses, y plus 3 equals 4 times y plus 4 times 3. Distributive. Okay. If we do, let's say, look at 87. 3 times a times b equals 3 times a times b. Associative. Okay. And the best way to practice these is to look at them and have the answer and check it immediately. You know, just go over several of them, make sure you have it right. When you have a number outside the parentheses, and then you say the outside one times the first one plus the outside one times the second one, okay, that's the distributive property. Okay. All right, then on 5-6, you had to evaluate each expression. So 3 squared means 3 times 3 or 9. Okay, when you have the same base and you have exponents, your rule is to subtract. So 5 minus 3 is 2, 9 squared, or 81. When you multiply, if you have the same base, you add the exponents. Let me show you that one just a minute. 5 squared times 5. Okay, this is the base, so they are the same. Now, your rule when you're multiplying, if you have the same base, you add your exponents. What's the exponent on that one right there?
1.
A 1. So you get 5 to the third. Good. Okay. Look at number 101 is 7 to the 0. Anything to the 0 is equal to 1. If I have this, it's still equal to 1. Okay. Let's see. What about a power of a power? 2 to the third squared. What do you do there?
Pray.
Multiply.
Right. 3 times 2 is 6. Okay. Alright. Then, next we had express it. And,
I'm sorry, how is that 6 if it's 2 to the third power? That would be 6 in itself, and then to the second power, wouldn't that make it 12?
what it means is 2 to the third times a 2 to the third. Okay. Which is a 2 to the 6th. Because, see, this means take whatever's in parentheses and do it 2 times. So that and that, your rule when you multiply, add your exponents. So instead of having to do that every time, it's a power of a power, you multiply them. Okay. And that, be sure to know where that chart is in your book, because that'll help you find, in case you forget how to do these rules. Okay, now, next ones were scientific notation. If you had 230 million like this, okay, you have to make it a number between 1 and 10. So if I put it here, that's 230. If I put it here, that's a 23. If I put it there, it's 2.3. So 2.3 is a number between 1 and 10. And I moved it from here, 3, 6, 7, 8. So 2.3 times 10 to the 8. Okay? Then you had problems where you did them backwards. Now notice if you have something like 10 to the negative 4, then that means it is going to be a tiny number or a small number or a fraction. Okay, let's see. A 113 and 114, I did not show you how to do those at all. I don't know if we had those or not. Yeah, we did. Okay. But I'm sure you looked in the back of the book and figured out what to do on that. Okay, so 113, let's look at the answer on that one. Okay, 283. Okay. Alright. 14 times 10. 13. Okay. Alright, so on that one, you had a, let's see, 7 times 10 to the third times 2 times 10 to the negative 5. So you might get a 14 times a 10 to the, whoops, I didn't do that right. Okay, to the negative 2. Okay, and then you can't leave it as 14, can you? So you have to move it 1. So that's a 1.4 times 10 to the what? Negative, is it negative 1 or negative 3? Okay. Okay, so, in the back, okay, so, those were those types of problems. Okay, any of them that you, out of all of that, if you didn't get it figured out, that you need to see worked out? All those on the chapter review. I thought that was a good review of everything that we
But
have had. all those.
79 real quick.
Okay. 79. Okay. That's a good one. Okay, radical 3 times 4 plus radical 6. Okay, so 4 times radical 3 is 4 on radical 3, plus radical 3 times radical 6 is radical 18, right? Okay. What property are you using here? Distributive. Okay. Now, we would break this one down into 9 times 2. Square root of 9 is 3, bring it out. Okay. Is that right?
Yes.
Okay. And these are not alike, so you have to leave it like that. Okay. So they get kind of harder and harder. Okay. Let's see. Now, if you want something to see if you know how to do these, then you just go back to each lesson and work a few problems that we have had. Now, some of them we didn't do, but like, especially like if you want to review scientific notation on page 261, see, it has, here's all these different problems. Here's the answers right here. So you can just work a problem, 2.88 times 10 to the 3, 6, 7, 8, and then you check it. Okay, that's the best way to study for math, is to work problems and that you know the answer to. Doesn't do you any good to work a G in problems that you don't know if you're getting right or not. Okay, also make sure you remember all your rules on this part right here. Okay, now I think we're ready to finish. Okay, let's
So for the next,
Okay.
next test that we have to memorize all the rules in order to do the test, right?
Okay, you pretty much need to know most of them. Yeah. Okay, let's see. Okay. Okay, so we have been in chapter 6, and we did, okay, look at 6.3 just a minute. This is on formulas. Okay, 6.3. This is on page 311. Okay, page 311. We have already done this one. This is 6.3, and it is using formulas. But I just want to show you how you cannot have any idea of what you're talking about, but can still come out with the right answer. Okay, look at number, let's say 20. Okay, number 20 on page 311. Okay, you have M equals A plus B over 2. Find A when M is 70 and B is 77. Okay, now, so in place of M, we're going to put a 70. A, we don't know, that's what we're trying to find. B is 77, and here's a 2. Okay, so there's our problem. Now, you're not always finding the one that's over here by itself. Okay, see, on this one, it's kind of different. Now, how could I work this? You remember your whole reason, if you're trying to find A, you want it by itself and everything else on the other side. What could I do to make it a simpler problem?
A over 2 plus 77 plus over 2. Break it down.
You can do it like that, but you can do it even a step easier. If this is right, if this is division, you do the opposite or multiply by 2, like that, and that will remove that out of the denominator. So that's a 140 equals A plus 77. Now it's a simple equation, and you subtract 77 from both sides, and that gives you what A is equal to, right there. Okay, let's see, down at the bottom, 22 and 23, so you're using those formulas that we were working with. Okay, next page, see, they look horrible, a lot of them, but it's like, look at number 25. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Find M when y sub 2 is 8 and y sub 1 is negative 4. Okay, you don't have any idea what you're talking about there, but you're really talking about slope of a line. Okay, and so x sub 2 is negative 3 and x sub 1 is a negative 5. Okay, you put those in and see what you get for the answer, number 25. Just tell me where you want to do it.
This is the first time I've seen those sub
Right.
I don't really know how to treat them. Like
Just think of that as an A and a B and a C and a D or something like that. Okay. Just put numbers in place of those. And when you get an answer, check it in the back and see if it's right. This is number 25.
Probably need to start putting a bookmark in the answer section.
Yep, that's the easiest thing to do. Because you need it all the time. Did you get it?
I got a -6.
Should be positive, I believe, isn't it?
That's what it says.
Okay.
But when you divide
Mm-hmm.
a negative or a positive into a negative, doesn't it make it negative?
Okay, let's look and see. Okay, so on the top, that becomes a 12. This one becomes a 2. Okay, and then 2 and 12, 6 times. Okay, you probably made a mistake right there on
But it-
subtracting. -3 minus a -5.
You gave me the +2, but I got a -12 on the 8 minus -4.
Okay, an 8 minus a negative. Double negative, so it makes it positive. Okay, all right, now, later on, we will actually be working problems finding the slope of a line. But right now, we don't even know what that's talking about. But you can still get the right answer. But it helps if you know what it's talking about. So you can check your answer. But anyway, that's what all of those on that page are. And this is really the main and only reason, unless you're going to go into something with a lot of math, that you need to know algebra is to solve an equation. Okay, now the next section, which is 6.4, is linear equations in one variable. Okay, and you think, okay, what are we talking about here? Okay, these are equations that form a line, but they only have one variable in them. Okay, and in order to work these, you have to know what some different words mean. Okay, so if we're going to do notes for 6.4, okay, and these are going to be expressions that we're going to change from words into numbers, okay, and if you put these in your notes, this will help you, get your answer. Okay, the first one is 6 more than a number. Okay, 6 more than a number. Okay, I'm going to let n or x represent my number. Okay, and I want 6 more than that. So that will be n plus 6. Okay, all right. Number 2, a number increased by 3. Okay? You've got a number and you're going to increase it by 3. Well, plus 3. Increase by 3. Next one, 4 less than a number. 4 less than a number. Okay, so I've got 4. It's going to be less than something. It's going to be less than the number. Now, put 2 little lines under less than. Okay, because I'm going to show you the next one. 4 less a number. 4 less a number. Okay, look at the difference in those. Now, if you miss any, changing these from one thing to another, it will be less and less than. Okay, 4 less a number. It's just straight out. 4 less a number. 4 less than, what's it less than? It's less than a number. Okay, now, number 5. 3 decreased by a number. 3 decreased by a number. Is this going to be 3 minus n or n minus 3?
3 minus n.
Good. Okay. 3 decreased by something is decreased by a number. Okay, now.
So it's literally just like the word display out, almost.
Except for the less than. Exactly. Okay, now, these are expressions. Next, we're going to do equations. What does an equation have in it? Equations have an equal sign in it. Okay, so we're going to write the equation and then solve it. The sum of a number and 7 is 15. The sum of a number and 7 is 15. Now keep in mind that in equations, the is the equal sign. Okay? So, the sum of a number and 7. How would I write that?
N plus 7
Mhm.
equals 15.
Equals 15. And then you solve it. Okay. Okay. All right, so I would subtract 7 from both sides, so n equals 8. So the sum of 8 and 7 is 15. Okay, so you're just changing these words into symbols and equations and then solving them. Okay, the second one, 4 times a number decreased by 10 is 42. 4 times a number decreased by 10 is 42. Okay, so write what you think that looks like. And then we'll check it before you work it.
Would be n minus 10 equals 42, which would be 52 equals n.
4 times a number, 4n, decreased by 10 is equals 42. Okay? Okay, so to solve that, that's an ax plus b equals c type, so that's 4n equals 52. Divide through by 4. Is that 13? So 4 times 13 minus 10 gives you 42. Okay? Number 3. A number divided by 3 is 4 less than the number. And this will be the hardest one. Okay. Okay, so a number divided by 3 is 4 less than the number. 4 less than the number. I don't think that's going to work. Or we're going to have ends on both sides. Okay, let me see. Okay. Alright, so what I would do is multiply by 3. And that, you'd have to use 3n minus 12. Okay, let's see if that works. A number divided by 3 is 4 less than 6. 2 equals 2. Okay, so that does work.
May I run the rest of the
Okay. Now, what we're going to do now is see if we can write an equation and then solve it. Uh-oh. There's one I need to show you how to do first. And that is consecutive integers. If I can find that. Okay. I don't know where my notes on this part are. I'll have to make some up here. Let's see. I think what we're going to have to do is do these together. Okay. You can go ahead and do the first 3 or 4. And then we'll do these other ones together. I'll be back in just a minute. Okay, now you probably had no problem with 1, 2, and 3. And the other ones we have not had how to do yet. Okay, 10 more than a certain number is 12. Okay. And what's the number?
2.
Mm-hmm. Okay. Second one, 3 less than a certain number is 9. Okay. So add a 3. Okay. Number 3.
All these
What?
wait, I thought that was 6.
Okay.
No, never mind. I'm an idiot.
Oh, wait a minute.
You're
Okay.
right.
Okay.
If in the future,
Mm-hmm.
like if we were to ever have different instructors and we didn't put all the steps to it, they count off for it.
Depends on the teacher. 4 more than twice a number. All right. 4 more than something. It's 4 more than twice a number. Is 8. Is that the way yours look? Okay. Subtract 4. So 2n equals 4 divided by 2. So n is 2. Okay. Now, okay, number 4 we have not had how to do. Okay, so I'm going to show you how to do that one. Joe is 4 years older than Jim, and the sum of their ages is 46. How old is each? Okay, so write down Joe and Jim. Now, Joe is 4 years older than Jim. All right, we don't know anything at all about Jim, so he's going to be X. Okay, then it says Joe is 4 years older than him, so that would be X plus 4. The sum of their ages, X plus 4, equals 46. Okay, that makes sense? Okay, so I always put down, if you've got 2 different things, put down the 2 things. The one that you know absolutely nothing about is X. And then it said the sum of their ages, so add those together, is. Alright, so that's a 2x plus 4 equals 46. Subtract 4. 2x equals 42. Divide by 2. X is what, 21? So who's 21?
Jim.
Jim. And then Joe is 21 plus 4, or 25. Is the sum of their ages 46?
Yes.
Yes. Okay. That makes sense? Okay. All right. Number 5. Okay. Number 5. Okay. 5 less than 3 times the number is 40. All right. We know that is 40 is going to go over there, right? Equals 40. All right. Okay. 5 less than 3 times the number. All right. 5 is going to be less than something. And it's going to be less than 3 times a number. That makes sense? 5 less than 3 times n is 40. Okay? Then solve it and tell me what you get.
15.
Okay? Because you add 5. So 3n equals 45 divided by 3. So that's 15. Let's see if that works. 3 times 15 is 45 minus 5 is 40. Okay, number 6, a different type of problem. The width of a rectangle is 5 feet less than its length. If the perimeter is 66, find its dimensions. Okay, so this one, I would draw a rectangle. Okay, the width is 5 feet less than its length. Okay, here's the length and here's the width. Okay, the width is 5 feet less than its length. Okay, so which one do we not know anything about, the width or the length? Length. Okay. So the length, we're going to let it be X, or we can let it be L, whatever you want to do. But anyway, that's the one you don't know anything about. This one is 5 feet less than that. So the width is going to be X minus 5. This one is 5 feet shorter than that one. If you want to use L's, you know, for your length and width, that's fine. Now, we've got to find, it says the perimeter is 66. Perimeter means all the way around. Okay. So, here we've got an X and an X, because opposite sides of a rectangle equal. Here we have an X minus 5, and here we have an X minus 5. So if we add all that up, we get the perimeter. So X plus X plus X minus 5 plus X minus 5 gives me 66. Okay, so altogether we have 4 X's minus 10 equals 66. Add 10, so 4x equals 76. Divide by 4, is that 19? So x was our length. So if this is 19, this is 19. This would be 19 minus 5, or 14. And 14. And then add all that up and see if it adds up to 66. Then you'll know if you have it right or not. Okay. Alright, and anytime it's something like with perimeter or area or something like that, draw a picture so that it will make sense to you. Okay, let's see. Alright, the next one is one you have also not had one like. The sum of two consecutive odd integers is 28. Find the integers. Okay, before we do that one, we're going to do an easier one. Let's say we have a, okay, let's see, put this back in your notes. The sum of two consecutive integers is 41. Find the integers. The sum of two consecutive integers is 41. Find the integers. Okay, consecutive means one after the other. Okay, so we got two numbers that we're going to add together and get 41. So we've got the first one and we have the second one. So we got x and we have the next one. How much bigger would the next one be than the first one? X plus 1. Okay. So if we add these together, excuse me. So that's 2x plus 1 equals 41. Okay. Okay, does that make sense?
Couldn't that literally be
Together. Like 20 and a 21 add up to 41. Now,
Are we in the number 7, right?
okay, and that's not the one that's on the paper.
Oh,
Okay, okay, this is just a separate one. Okay. Now, if you have two numbers, like a 16 and a 17, those are consecutive, right? If you have a 20 and a 22, those would be consecutive, even. I haven't had to talk this much lately. I'm not going to make it. I got a cough drop.
consecutive?
Okay. All right, now, if you want to represent consecutive even, you have an x and an x plus 2. If you want to represent consecutive odd, you'd have an x. How much bigger is this one than that one? Okay. It looks like it would be an x plus 1, doesn't it? Okay, but it's not. You would still represent them the same way. Now let's do number 7.
Thirteen and 15.
Mm-hmm. Check it. Okay. So, see how I did that? Alright.
Be a test, but could you go over number 6 one more time?
Mm-hmm. This one. Okay. Okay. We don't know anything at all about the length, so that's going to be our x. And it might even help if you just didn't put that on there. Opposite sides are equal. If you add them all up, they're going to equal 66. Does that help? Sorry.
Okay.
Okay.
No.
Okay. Alright, on 6-4, do 3 through 25 odds. And 27 and 33. Check them in the back when you finish, so you'll know if you have it right. Okay, and you can take a break before you do that, or you can. Mm. Mm. Mm.
Do you know when is Jeremy coming back?
Jeremy,
Yeah,
he's back.
he's back
He
now.
got back last night.
Uh-huh.
And then he had to leave early this morning to go to Washington, D.C. with his daughter. Their class at Mars Hill was
Uh-huh.
going on a tour of
Oh.
so he's going to be very tired.
So how many days he will be in Washington?
I'm not sure, 4 or 5, I think, something like that.
So it's a long journey from here.
Uh-huh. It's about, they're going by bus, so I think it's like 15, 16 hours, something like that.
Wow.
Terrible.
Yeah.
Okay. He sent me a picture. Let me see if I can find it. I don't think I have it. Well, I don't have it.
Yeah, it's okay.
Yeah, Joey got back yesterday too. They're on different planes, so.
Oh.
Time to follow the birds to Mexico.
What?
It says time to follow the birds to Mexico.
Oh.
So they will, in Mexico will be warm.
Yeah. Oh yeah.
Mhm.
That's it.
Let's see. Mhm.
Did your boys make it back yet?
Yes, both of them are back. Well, and I told him Jeremy had to leave going to Washington D.C. Early this morning.
No, poor man.
His class was, his daughter's class was going to Washington. They have a real good trip up there, though.
And they went to Burma?
Yeah.
Or-
They went to, Joey went to Burma and then Vietnam. Jeremy went to Vietnam, Philippines, and then back to Vietnam. He was like in Hanoi and then Philippines and then Ho Chi Minh and around.
When I look at the journey, it's kind of weird to me.
Yes.
You are in Hanoi, then you can fly directly to Ho Chi Minh City, then go to Philippines. Why you go to Hanoi, then Philippines, then go back to Vietnam?
Because of price.
Yeah.
Yeah.
You have to go a certain way because you can't afford it to
It's
go
cheaper
other
to do
ways.
one way than just, I mean, round trip and then just keep doing one
Yeah,
way, one
you
way,
have to
one
make
way.
loops
Yeah.
different places because sometimes, like Joey, Singapore was his base, so we had to fly to Singapore and then go to Burma, back to Singapore, and then Ho Chi Minh, and then back to Singapore, and then back home.
See.
'Cause that's, you just can't. It would be so great if you could, because you can just go here, 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 and like that.
Yeah.
But it costs you about 10 times as much money.
Oh, yeah, I see.
It's
awful.
2017. Why don't we have the Star Trek transporters?
Exactly. Mm-hmm. Mm-mm.
What's your winters get like on? They get cold there, like just
No,
cool.
it's just cool. Just something with us like in the classroom. Yeah.
Oh, okay.
Mm-hmm.
So because in Vietnam I live in the south, so just 2 seasons, rainy season and hot season.
I love it.
Yeah.
I
So
would love that.
yeah. But for the north, they will have 4 seasons. So actually they have winter, but will be cold.
Yeah, it's crazy.
Yeah.
So y'all never really get to experience like a fall, like changing the leaves. And
No.
Mhm.
Because I live in the south, so no.
You will hear it gets so pretty because the leaves will turn
Next few
orange
weeks
and
you'll
red.
Uh-huh.
Yeah. And if you get to go up into the mountains around Gatlinburg, that's where Jesse is right now. It's beautiful. It's supposed to be the prettiest all year up there. Mhm. Yeah.
Also
It'll be
the
pretty
most packed. It's
Yes.
it's weird,
A whole lot of people there.
too. Go around Thanksgiving, you're like fighting for walking space.
Uh-huh. Okay. Next thing we're going to do is graph some inequalities on a number line. And I'm going to try not to talk too much, so just watch. Okay, that's what that would look like graphed. X is greater than 5, so you just have an open circle at 5 and then shade that way. Number 2, if you had a graph 2x is less than 3, you first have to solve it by dividing by 2. So x is less than 3 halves, or x is less than 1.5. Okay. Okay, so here's 1.5. Okay. It points that way, so you shade that way. This one pointed that way, so you shaded to the right. Okay. Then they get more and more complicated. Okay. It looks exactly like an equation, ax plus b equals c type of equation. You solve it. Okay. Now, when it's greater than or equal to, you fill in the circle. Okay? It's equal to, you fill it in. That's what you have to do. That makes sense?
Yeah.
Okay? Alright, this one gets harder. Okay? So you have to use the distributive property.
You did that.
Okay, so x is less than 2.5. Okay, so here's 1, 2, 3, so there's 2.5. Points that way, so you shade that way. It's just less than, so you leave it open. Okay? Here, I'll show you these. Now number 5. Okay. This is probably the hardest looking one. Okay, like this. Now, what would you do to both sides?
Multiply 2.
Multiply, and I would multiply by -2. Excuse me. Okay, so that cancels. Okay, it also makes this a positive. Okay, and then it turns this sign around. Okay, like signs are positive. So if you multiply or divide by a negative, you turn the inequality sign around. Okay, because what I wanted, this was a negative x right there. But I multiplied by -2, so that made that a positive. It turned this around. And so, equal to, shades it in, points this way, shades that way. Okay. Questions? Okay. On page, let's see, this is on 6-6. Now we omitted 6-5. Okay, do 7 through 31 odds, but omit number 23. I think that's the only one you omit. Okay, and this will give you practice solving equations and inequalities, but be sure and check each one in the back.
So now we can do it, right?
Gotta do it right now.
Which one did you? She's like, and steroids. Could not sit still. This one.
That is the distributed property. What time of day is this? Plus, 4.9, 1, 10, 11, 6.
That's not a minus one then?
It's the same thing.
Oh, duh.
Then you have to solve that. You doing okay?
Yeah.
Okay. Be sure when you finish,
square,
Mhm.
is it okay to have a negative x
I know.
like this?
You always want it to be positive, so if you divide through by negative one, it turns the sign around, and that makes it a negative one. You don't ever want your x to be a negative. So you just divide through by negative, and that switches the sign. Good question.
This one right here, this one right here says no solution.
Okay. Okay, is this a X on here?
Why would they do that? So you really can't put it on a graph then? Okay.
So whenever I have a negative x,
Uh-huh.
I can divide it by negative 1, or I can do the same thing. Okay.
Switches the sign.
sign
Mm-hmm.
this direction.
Mm-hmm.
Oh yeah, wrong. Thank you.
Mm-hmm.
I thought it'd have to be greater than, oh,
Well,
you're right, you're
It
right.
could be, you know, okay, it's greater than 6, okay, so it could be a 6.1.
Gotcha.
Okay, so what are you gonna do with that one? Okay, multiply by 3, right?
Mhm.
Okay, good.
So we'll go back to
Mhm.
-6,
Mhm.
and because it'll be equal to, you fill in each one, right?
Well,
Or
it'll
just-
just be the end one.
Okay.
Like, so x is less than or equal to -6.
So like on that
So
one,
we
I
find -6, 2, 3, 4, 5, 6. Okay. Goes that way on -6.
So on that one, I didn't need to fill in each one. Oh, okay.
Just makes it a solid line.
Okay.
Okay. And you divide it by -3. So that turns your inequality sign around. Okay. If you multiply or divide by negative, you have to turn around. So it should go this way, but it should be a solid all the way like that. Solid.
Gotcha. Yes, ma'am.
Remember to omit number 23.
What's the difference between an integer and a real number?
Okay, an integer is like whole numbers. You know, like, not really whole numbers, but positive numbers and negative numbers. And then if you've got a real number, it can be fractions, decimals, all sorts of different things.
So I'm gonna do like the same thing I was doing, right?
Mm-hmm. I'm wrong about that, because if it's an integer, it's only gonna be like this one, this one, this one, this one, because it doesn't include the fractions or anything. Get that on 55. Okay. Okay, you were actually doing it right. I hadn't read the instructions. Where it's supposed to be integers, so it was just supposed to be just the numbers like that. The other ones were real numbers, which included the fractions and the decimals, but these are only the dots.
Now, with that being negative x divided by 6, that would be x is negative and 6 is negative then, right?
Mhm.
So that would make it a positive number.
Well, right now, it's the whole thing is negative, so if you multiply by a negative, is that a 6?
Mm-hmm.
Okay. Then you get an x, turns this around. Okay, and you look at 18.
But it would still be
But I was wrong on those. Like I said, I haven't read the instructions. Okay.
So
Uh-huh.
so is this the way that we graph the integer?
Weird, isn't it? Yeah. I was telling him, I told Bobby long time ago, these you're graphing the integers, so it won't be a solid line, because the integers are just like 1, 2, 3, 4, 5, and it doesn't include the decimals and the fractions and stuff like that. So on 25, anything greater than 2, greater than or equal to 2, so 2, 3, 4, and so on.
Okay, then. Okay.
And I think they do like that to show, and so on. Okay.
So the next one, 27, will be negative 9, negative 18, and negative. So this one will be negative
Mhm.
9 and negative 18, right?
Well, you had to divide through by negative, so that
Yes.
turns your inequality sign.
Oh, okay.
So it'll be going this way, but negative 9, negative 8, negative 7, 26.
Oh,
Mhm.
27
ellipses,
Oh,
ellipses.
ellipses.
Isn't that a form of grammar too, ellipsis?
And I know this didn't look authentic. I mean, it's an integer to show that it's and so on. Thoughts up there.
So should we put in the
Mhm.
outside or inside?
That's kind of difficult up over it a little bit. How weird. Like it's like a real number, it's just solid, and then you get up a bit darker, you up here, or something like that. Okay, let's stop just a minute on that, and you can finish this later. I'm gonna give you some work on all the different lessons to do, before we have the test. But I wanted, you to look at lesson 6, 7. Okay, 6, 7. Okay, and this will start, if you look on page 335. Okay. This shows about graphing linear equations, which means equations that form a line. And when you have a coordinate system like this one is the x, this one is the y. You can remember because the y is like this, comes down. Okay, so this is the x, this is the y, this is the origin or the beginning. And so this man named, it tells you about it on the next page, Rene Descartes. He was a sickly person, but he was real smart. And he had to lay around in the bed a lot because he was sick, and so there was a fly on the ceiling, and so he figured out how you could explain where that fly was. And so he came up with the Cartesian coordinate system named after him. And I always think about Star Trek, you know, on how did Scotty know where to beam somebody up? If you did not have the coordinate system,
Just like
you,
coordinates on the latitude, longitude.
Uh-huh.
The same.
right. And so this one is the x, and so if I want to talk about a point that is at 2, 3, the x is first, the y is second. You always start at the origin, and so you go over 2 and then up 1, 2, 3. So that would be the point 2, 3. If I had a negative 4, 0, this one is always the x, and this one is always the y. So if I'm here, which direction will I go?
Go left.
Okay, on the x, negative 1, 2, 3, 4, and then I didn't go anywhere on the y, so it's right there. So this point is point B. So I always do the x first and the y, and that's easy because that's alphabetical, you know. Okay, if I have a point here, okay, what would be the coordinates of that point?
0 and negative 4.
Okay, which one would come first?
0.
Okay, and negative 4 because it didn't go anywhere on the x, but it went down on the y. Okay, like that. Okay, now we're going to be able to graph some equations by plotting some points. Okay, and what they mean by a linear equation is if the points are all in a line. Okay, like this, that would be graphing it. I want to show you some examples of how to do this. Our first one is going to be to graph y equals 2x plus 3 using plotting points. Okay, so what I'm going to do is pick out a couple of positive numbers like 2 and 1. I'm going to use a 0, and I'm going to use a negative 1 and a negative 2. And if I substitute 2 in place of x, what will y become?
That will be
7? 2 times 2 is 4, plus 3 is 7. If I substitute a 1 in for x, okay, if I substitute a 0 in, 3. Now, sometimes you might want to write them down when you're using the negatives, but that's negative 2 plus 3 is a 1. If I did a negative 2, that's negative 4 plus 3, or a negative 1, okay? Now, what's good about this, by picking out about 5 points, you can check yourself and make sure that you're doing them right. So you've got 1, 2, and then 1, 2, 3, 4, 5, 6, 7. I've got 1 and 1, 2, 3, 4, 5. I have a 0 and 1, 2, 3. I have a negative 1 and a 1, and a negative 2 and a negative 1. Okay, so if you're using graph paper, then it should come out exactly right. Now, the reason we usually use 5 is because if you're plotting down through here and 1 ends up over there, you know you made a mistake. But if you only pick out 3 numbers, you won't know which ones were right and which ones were wrong. So that's the reason we usually use some of those. Okay, let's look at another one. Let's say we have y equals a negative x plus 4. Okay, so I'm going to use 2, 1, 0, negative 1, and negative 2. Okay, if I put in 2 here, that's negative 2 plus 4, or a 2. If I put in negative 1 plus 4, a 3, a 0 plus 4, 4, a negative 1, that makes that a positive 1 plus 4, or a 5, and that makes that a positive 2 plus 4, or a 6. So if you graph this one, you've got 2 and 2, 1 and 3, 0 and 4, negative 1 and 5, and negative 2 and 6. Okay, and I just guessed on those. Okay, all right, so there's that one. Okay, let's look at another one. Let's say we have y equals x. Okay, here's x, and here's y. That one's easy, isn't it? So if that's 2, that's 2. That's 1, 0, negative 1, negative 2. If I graph it, I've got 2, 2, 1, 1, 0, 0, negative 1, negative 1, negative 2, negative 2. And there's my line. Okay? If I have y equals 1/3 x plus 1. Now, I would not use the same numbers if I had a fraction right here. Because if I put a 2 in there, that's going to end up with a fraction. It's going to be hard to figure up in your head and everything. So I might use like a 6, a 3, a 0, a negative 3, and a negative 6. Alright, so if I put 6 in here, 1/3 of 6 is a 2, plus 1 is 3. If I put a 3 in there, that ends up being a 1 plus 1, or 2. If I put a 0 in there, that part's 0, so that's a 1. If I put a negative 3 in here, that ends up being a negative 1 plus 1, or a 0. If I put in a negative 6, that's a negative 2 plus 1, or what, a negative 1. So if you graph it, you got 1, 2, 3, 4, 5, 6, and 1, 2, 3. You've got a 3 and a 2. You got a 0 and a 1. You got a negative 3 and a 0, and a negative 6 and a negative 1. So that line comes out like that. Now, there's something you may or may not have noticed because I haven't done enough of them. But if this number right here is a positive, it goes in this direction. So this one was a positive 1. This one was a positive 1/3. They go this way. But if this number right here is a negative, it goes like that. Okay. All right. And there is another way to graph lines. You're not going to be required to know how to do it. But it's if your equation is in this form, it's y equals mx plus b. This is the slope right here. And this is the y-intercept, or where it crosses the y-axis. So, if you have a y equals 2x plus 3, I don't even have to do all that stuff I did a while ago. I know it's going to cross at 3. all right? Then this is my slope, and I'm going to make it a fraction. I'm going to go up 2 and over 1. It's easier to do like that, isn't it? Okay, if you have, let's do some of these that we did a while ago. Y equals negative x plus 4. Okay, here's my y-intercept. 1, 2, 3, 4. That's the same thing as a negative 1 over 1, negative 1, down 1. So it's like that. If I have y equals 2x plus, let's say, negative 1. It crosses at negative 1. And I go up 2 and over 1. Okay, so there are about 1,000 things that you can do with equations. You can graph equations that look like this. Y equals x squared. Okay, if I did an XY chart on that, and I did 2, 1, 0, negative 1, negative 2, 2 squared would be a 4, 1 squared would be a 1, 0 squared would be 0, a negative 1 squared would be 1, a negative 2 squared would be 4. So when I graph that, I'd go 1, 2, and then 1, 2, 3, 4. I would go 1, 1. I would go 0, 0, negative 1, 1, negative 2, 4. So if you have a square, it makes a parabola shape. So there's all different kinds of things that you can do with this. There's one type, it'll make your parabola go that way. And other types, you can make it go that way or down like that. And you can tell by looking at the equation which way the line's going to go and all that kind of stuff. And but anyway, I just wanted to show you different things that you can do with equations. Okay, now the problems that we're going to do on this chapter are these right here. Now these are the ones that you were already working on. Okay, so you need to finish those. But 6-1, 9 through 37, 6-2, so forth and so on. And this will review all of chapter 6. Now if you want to work these on 6-7 while I'm here, you know, so in case you have a question about those, you can, or you can just start at the beginning and do it whichever way you want to do it. But next week we will not be here because it's fall break if I'm right. Is that correct? Okay, good. All right, and then the week when we come back, we will take a test over everything that we've had. Basic math and chapters 1 through 6. Okay. Okay, so when we come back again, and this will be on October the 31st, right? Okay, all right. Now, if you have any questions in between now and then, you know, just text me, show me the problem, I'll show you how to work it, send you a picture back or whatever. Okay, but be sure when you're working on these problems that you check in the back to see if you have the right answer or not. But all you have to do on the equation, on the graphing these linear equations, they all will form a line. Okay, is use that little XY chart and do like the 2, 1, 0, blah, blah, blah. Okay. And I was going to give you some graph paper in case you needed it for those problems on 6, 7. Okay, have any questions?
I don't know, I think easier when you can see it.
I can't explain it.
Right. And if you need anything from me, let me know. And I would be sure before the test to just kind of review everything that we've had, work a couple of problems that you know the answers to, and then I will check these and see that you have them. But I always give you problems that you have the answers to so that you'll know if you're getting it right or if you're getting it wrong. See. And you can just continue to work until it's time for chapel. And I'll be here to help you. You can start wherever you want to. If you want to finish what you were doing, you can, or work on 6, 7, or start at the beginning. It doesn't matter to me. Now be sure and check and see if you've done any of these before, because I could have already assigned some of them.
I was just thinking that.
And if you need to go back